guys, I hope you're doing great today. Today we are going to discuss CI/CD interview questions and answers. Whenever you are going to take an interview, you are asked about CI/CD a lot because we have discussed that CI/CD is the backbone of DevOps, so you can expect a lot of questions regarding CI/CD, the importance of CI/CD, what is CI/CD. You can be asked about different stages in a CI/CD pipeline, or what are the different steps to create a CI/CD pipeline, what is artifact management, what is build stage, and so on. So if you want to revise your CI/CD concepts, you have to watch my earlier videos in which we have discussed about what is CI/CD, how CI/CD works, and what is a CI/CD pipeline. We have discussed this in detail. Now it's time to see how much we know about CI/CD, and I have prepared this document with real-time 40 CI/CD interview questions and answers. So guys, I would also appreciate your support. Please subscribe my YouTube channel DevOps Molvi on YouTube. Let's get started with our CI/CD, which stands for continuous integration and continuous deployment or continuous delivery. So here comes our first question. What are the key stages in a CI/CD pipeline? Let's start with the basic ones. So we know what are the stages in a CI/CD pipeline. I mean, how CI/CD pipeline works. What is done at the first step, and then what is done at the last step. CI/CD pipeline is the combination of both continuous integration and continuous deployment or continuous delivery. There would be another question about the difference between continuous deployment and continuous delivery. That would come later, but these are actually the 8 most common stages of a CI/CD pipeline that are practiced in every IT organization. So first is source code management. We know that we have our source code on GitLab or GitHub or Bitbucket. So these are cloud hosting code repositories. So whenever a developer is writing the code, definitely he or she is committing that code. So first step is the changes in the code, right? After all, we are going to test, or we are going to check our CI/CD pipeline by modifying our code, whether our code works or not. So this would be our first step, code commit or version control, which means that the changes happening in the code. So the second, when there is a change, the code starts building and compilation. That is the second stage. And after that, we test our code for any potential errors. So it is unit testing, it can be integration testing, it can be regression testing. Then code coverage, okay, in which our code is checked for code quality analysis. And then we have integration testing. For instance, our code has some modules and there are any plugins. So we test the integration using integration tests, and then our code is built into artifacts. Those artifacts or images are pushed towards our Azure repository or Elastic Container repository or Docker Hub, and then those images or those artifacts are deployed on our cloud environment or on our deployment machines. So the last step is performance testing, whether our CI/CD pipeline was executed fine, all the steps were carried out without any issues. Performance testing means monitoring, logging, and analysis. Final performance testing using Grafana, Prometheus, and tools like that. So these are actually the 8 general steps, you can say that, of a CI/CD pipeline, or these are the key stages of a CI/CD pipeline. Question number 2. What is code commit and version control stage? Now these can be 8 different questions. Guys, these are actually the stages of a CI/CD pipeline. So you can expect these different 8 separate questions. Uh, what is source code management? What is build stage? What is the difference between unit testing and regression testing? Or what is the difference between unit testing and integration testing or end-to-end testing? And what are the F artifact repositories? So these can be different separate questions. So first, what is the code commit and version control stage? This is actually the first stage in a CI/CD pipeline in which the code is commit and version control software where our code is hosted like Git, and developers write code and commit it to a version control system like Git. So this stage ensures that every change we made to the code base is tracked and recorded. Whatever developer is committing, we must track the changes happening inside the code. So this is the first stage, and after that our CI/CD pipeline starts building. What is the build stage? Question number 3. The build stage is responsible for building the binary, container, or executable program for the project. This stage validates that the application is buildable and provides a testable artifact. When the code is commit, the code starts building and compilation, and at the end we get an artifact like jar file. Okay, in Java we get jar file and similarly other artifacts. So the build actually builds the code and compiles the code with dependencies, and this is our second stage of a CI/CD pipeline. Question number 4. How long should a build take? And after a detailed research on Google, I found that people and different developers and experienced DevOps professionals were also saying the same opinion that I had, that developers should get results for their CI/CD pipeline in less than 10 minutes. 10 minutes is more. But this is not, a universal truth that every CI/CD pipeline should take 10 minutes. I remember there was a pipeline which were having some Maven project and a lot of modules in Java, Maven Java, and that pipeline was taking 50 minutes for the first time. And that pipeline was taking 50 minutes to build. So after that, the build was taking less time, but for the very first time, the pipeline was taking a lot of time. And then after fixing the errors and issues, that same pipeline was taking around 6 or 7 minutes. So you can keep in your mind about 10 minutes of a build that should normally take, and that's the longest time and practical to wait for the results. We should have the results in 10 minutes. Okay, but this is a general, a standard. Okay, maybe your pipeline takes 2 minutes, maybe your pipeline takes 30 minutes. So that is actually the standard time which should be observed. And if that pipeline is taking so long, then you must check for any potential issues. Question number 5. What is the difference between continuous deployment and continuous delivery? We know continuous integration, which is related to code compilation, code building. Now, after that, we have that artifact. We are going to deploy that artifact. So there are two actually techniques, there are two mechanisms, or there are two ways to deploy. One is continuous deployment, which is fully automated, and there is no manual intervention. And in continuous delivery, we have a manual intervention involved. After the tests are checked by a DevOps architect or a DevOps engineer, then that code is deployed or artifact is deployed on the deployment environment. So that is the key difference. Continuous deployment is fully automatic, and continuous delivery needs manual intervention so that we can deploy our code changes to the production. Okay. What are this? Question number 6. What are some of the deployment strategies? Now, this is also one of the most frequently asked questions, that which strategy do you adopt to deploy the code? So the first one is regular releases, Canary releases, and blue-green releases. There is quite a huge difference between each deployment strategy. And let's discuss them one by one in our next questions. Question number 7, how would you explain regular releases in a simple way? That is actually the most observed deployment strategy in IT companies, and it is actually the regular release, and in which software is made available to the public through a single release. We have the final version that is available for the public, that is available as the final release. So it is a regular release, and there are no multiple releases in this deployment strategy. What is the difference between Canary and blue-green releases? We have regular releases in which we have the final one release. Okay, now what do we mean? This is also, we can say, the definition or the difference between Canary releases and blue-green releases. Now let's see what we have. These releases are intended to reduce the risk of failure by exposing a small fraction of the user base, around 1%, to the release. Not all the release is available to the public. That is actually the key point that you must know. As a part of a Canary release, developers gradually transition users to the new release in a controlled manner. For instance, if a release has 10 points, okay, 10 parts, not all the parts are available at one time to the public. In Canary, one part or one module, let's say we say it module of that release, then the second module, then third. So not, and making it to the 100% by gradually taking steps, so that at the end the public has the final version of the code. So Canary releases involves step by step of the releases. Not, the release is not available to the public in one step. It is subdivided into steps, and developers take extreme care to make their code available in a controlled manner. Okay, that is actually the difference. And now, what is blue-green releases? And it involves running two instances of an application simultaneously. If one fails, that is just like if you know about load balancer. If one server fails, then the load is shifted to the second server. Similarly, you can say that if one release is failed, one is the current stable version, okay, which is known as blue, and the other is the most recent version. An immediate switch is made from the old version to the new one. If there is a problems, users can immediately revert to the previous version, which is safer than regular or big bang releases. So this is actually the same thing that I have shared the example of load balancers. If the traffic is distributed on both servers, if one failed, then the traffic is reverted to the current server, which is running fine. So that is the stable version, and this is the newest version. If the newest version fails, then we have this stable version, and it is a safe approach to that, so that our code, our product, it is available to the public. So now, if I quickly revise, in regular release, we have the final release at one time. In Canary release, we make our code available to the public in steps, 1%, 2%, 3%. And in blue-green releases, we have two versions, the stable version and the most recent or updated version. If somehow the updated or recent version fails, our branch or our pipeline or release is rolled back to the stable version. I hope now that you have your concepts cleared about regular, Canary, and blue-green releases. Question number 9. Is automated testing always a good idea in a CI/CD pipeline? Yes, of course. Because without testing, there would be no feedback loop to determine whether the application is release ready. How we can say that if our code is ready to be deployed? After all, we have to carry out integration test or unit test so that we know that there are no potential errors or vulnerabilities in the code. So without testing, we cannot say that our application is release ready. So automated testing is always a good idea in a CI/CD pipeline. Question number 10. Name a few types of tests used in software development. Okay, now, by the way, this is related to QA, because quality assurance team, the those guys carry out such tests, but they are also part of our DevOps CI/CD pipeline. So we must have ideas about these tests: unit tests, integration tests, end-to-end tests, static tests, and security tests. So unit tests validate that functions or classes behave as expected. There are no changes, there are no failures. Integration tests are used to verify that the different components, like I said, different modules of an application all work together. There is no broken integration or broken module. End-to-end tests check an application by simulating user interaction. Static tests to find defects in code without actually executing it. And security test in which the whole code is scanned and the application dependencies for known security issues or vulnerabilities. So these are 5 different tests that are carried out depending on the pipeline or depending on the code. Question number 11. What is code coverage? Code coverage is a measurement of how many lines, blocks, arcs of your code are executed while the automated tests are running. So we get the result in which the code is 80% covered or 70% covered. Now we know that it is the measurement and it is actually the testing of the code, and the lines and blocks of our code are executed in code coverage. And the tool like SonarQube is used. We have questions regarding SonarQube as well. How we can measure the code coverage? So code coverage is measured by using a specialized tool to instrument the binaries, to adding tracing calls and run a full set of automated tests against the instrumented product. A good tool will give you not only the percentage of the code that is executed, but also will allow you to drill into the data and see exactly which lines of code were executed during a particular test. So that actually our full code is checked for any potential issues, and that is actually code coverage. So we have a full report generated in which our whole code is checked for any potential issues. So that is actually the code coverage. Do you aim for 100% code coverage? And the answer is 100% is difficult to achieve. Also, 100% code coverage doesn't mean that everything is tested completely. So it is not possible that everything is tested. So we can expect 80% code coverage or 70%. If it is 90%, then it is a great and good code coverage. So aiming 100% code coverage, it is actually a very difficult move, by the way. Question number 14. What are the benefits of code quality analysis tools? The code quality analysis tools help identify potential code smells. Now, this is all relevant to code coverage. And now we have code quality analysis tools, and they check for security vulnerabilities and maintainability issues. Can you name a few code quality analysis tools? Which one did you use? You can tell which one, if any of these tools, or there are actually a lot of other tools, but I have highlighted the most frequently used tools like SonarQube, Codesi, Corti, Coverty, Fortify, and among I have used SonarQube. Why do you think about that we should use SonarQube? Why you should use SonarQube? Because it is the most common tool for code coverage, and it makes it easier for the team members to decrease application size, code complexity, time and cost of maintenance, and make code easier to read and understand. These are actually the advantages of SonarQube. So you can answer the advantages as well, and this is the reason why most of the IT companies use SonarQube. Does SonarQube need a database? If yes, why? And the answer is yes. SonarQube needs a database, and the reason is we have to save the results of the analysis. After all, when SonarQube tests the code, a report is generated, and we need to save this report for our further usage for future references. Then this database, the purpose of that database is to save the results of the analysis. So SonarQube definitely needs the database, and that is the purpose, to save the results of the analysis. Question number 18, would you mind sharing few benefits of SonarQube? Now, these are other some of the 4 benefits that I have gone through and studied about open. So these are actually the 4 major SonarQube benefits. It is open source, it supports various languages, and it reports duplicate code. That is actually the beauty of SonarQube code. It highlights the code which is duplicate, and code coverage obviously, and it is used for unit testing, code complexity, and other benefits. We can also integrate SonarQube with build tools like Gradle and Ant for code coverage. The core purpose of SonarQube is for code coverage, so it can be integrated with build tools like Gradle and Ant. Question number 19. You told a CI/CD stage as artifact management. We discussed about artifact management. This is one of the important stages in a CI/CD pipeline. So what is artifact management? So artifact management involves storing and managing the build artifacts generated during the CI/CD pipeline, like Docker images. And those images are pushed to the Azure repository, ECRs, Docker Hub, etc. Question number 21. How are the artifacts used for deployments? Now we have artifacts stored in our repositories. How would we use them? We will use deployment artifacts which contain all the necessary components required to deploy our application code to a specific environment. We have Docker images. We can run them anywhere on any environment, over the cloud or on-prem, or any VMs. So we have Docker images as the best form of artifacts. So the artifacts are referenced in a pipeline stage for automated deployment to the target environment. We have artifacts, now we can deploy them to our cloud environment. Question number 22. What exactly should you do if your build fails in a CI/CD process? Build is failed. Now, what should I do? And it is also an issue with the code. It can be, and we must coordinate with the development team while carrying out the following steps. Now, there is also involvement of the developers. Now, DevOps engineers and developers work together to fix the failing build. We can review the build logs. We can reproduce the issue locally on our machines, on our local personal computers. We can check for the configuration errors and also the version conflicts. Sometimes it is happening due to versions as well. So that's how we can fix the build failing errors, and it definitely involves development team as well. Question number 23. In what situations would a continuous deployment strategy is not be appropriate? So why should not we use why we shouldn't use continuous deployment in any strategy, any given strategy? If our products users are businesses, actually now this is something very critical. We must not deploy automatically into the production if our users are businesses that heavily depend on our application. Okay, and because it can affect their businesses and certain changes could disrupt their workflow, and continuous deployment should not be the best approach used here. In such cases we can use continuous delivery, which involves uh, manual intervention, and it is more appropriate. Question number 24: how do you monitor a CI/CD pipeline? Now, we are discussing questions as per our CI/CD pipeline stages. Now, our monitoring stage. And the common strategy is to use automated monitoring tools like Prometheus, Grafana, ELK, which provide real time status updates of each state of the pipeline, such as builds, tests, deployments, and alert the development team if anything fails. So that's how we can monitor a CI/CD pipeline using monitoring tools like Prometheus, Grafana, and ELK, and they will alert development and DevOps teams, for instance, if anything gets failed or for any issues. How to efficiently monitor a CI/CD pipeline? How we can efficiently monitor? And the answer is we must check metrics like how long each stage of the pipeline takes. Okay, that is the first step. The frequency of the build failures and the duration of downtime when a failure occurs. Longer the duration of failure, it means something is dangerous. And I have discussed the tools, these tools: Prometheus, Grafana, and ELK, Elasticsearch, Logstash, Kibana, can come in handy for this purpose. These monitoring measures enable the team to maintain a high performing and reliable CI/CD pipeline. Question number 26: have you used Docker in the CI/CD pipeline? You must have used. I hope that. If yes, how? Yes, I did. The pipelines that I have worked on were using Docker during the CI/CD pipeline process. After the builds were successful, we were building the Docker images, and those images were run into containers on the deployment environments with the help of Docker. So we were running Docker containers we were running our applications into Docker containers. How containerization can boost CI/CD pipeline scalability? After all, containerization helps a lot in CI/CD pipelines, and we must implement containers in a CI/CD pipeline because it improves scalability and deployment speed. Because containers are lightweight and standalone, they can be rapidly spin up or down, allowing for easy scaling in response to demand. So we must have containerization in our CI/CD pipeline, and the most favorite tool is to use Docker. Question number 28: what are runners in CI/CD? The runners are actually lightweight, highly scalable agents that pick up CI/CD pipeline jobs and run those jobs as outlined in the pipeline. So these are actually, runners can be a Docker container, runner can be a VM, and they are used to run CI/CD pipeline jobs. We can use GitHub Actions and GitLab runners, or we can also have our own, which is known as self-hosted runners. So runners are agents that pick up CI/CD pipeline jobs. Question number 29: how would you differentiate GitHub, GitLab versus self-hosted runners? That is actually an important question. GitHub and GitLab, where we store our code, have runners for CI/CD pipelines, and they offer a quicker, simpler way to run our workflows. While self-hosted runners are a highly configurable way to run workflows in our own custom environment. So we have to build our own runners, VMs, and those are known as self-hosted runners. And GitHub and GitLab CI also offer free runners to run our workflows on GitHub Actions or GitLab CI/CD. Question number 30: can we create a self-hosted runner on our local VM? I have virtual machine on VMware, and it is possible we can, yes, and there are a couple of commands that we can execute to create our own self-hosted runner. Question number 31. How can we secure a CI/CD pipeline? And the answer is you have to remember these 7 steps. These are really important to secure a CI/CD pipeline. And the first is to implement strong access controls. The second is secure access to code repositories. Our code repositories must have private access and not available to the public on cloud. And we must avoid hard coding secrets. Instead, we must have secret managers to use for secrets and passwords and keys like AWS keys, etc. And we must keep performing application security tests from time to time. And we must implement security focused CI/CD workflows. And the sixth step is to use rollbacks to enforce security in production pipelines. Number 7, to detect and remediate threats at runtime. So these are actually the 7 key important points to secure a CI/CD pipeline. Question number 32. How do you handle secrets in a CI/CD pipeline? And the answer is we can practice the following steps. We need to remember these steps are best to handle secrets in a CI/CD pipeline. We must not use hard-coded secrets, okay? And we should also use one-time passwords, OTPs, for more sensitive data. And we should also keep our secrets in secrets managers. So these are actually the steps to protect our secrets while running CI/CD pipelines. Question number 33. What is an approval gate in a CI/CD pipeline? That question is also simple, but it is really important. And in some cases, we implement manual approval gates, okay? And someone is going to approve your request so that after the approval, pipeline would run. And that is known as an approval gate to allow stakeholders to review and approve changes before they proceed to be deployed to production. This is often a step in continuous delivery, and that pipeline is not fully automated. So definitely we need a human intervention. We need an approval, and that is known as an approval gate so that our code can be deployed to production. Question number 34. Please define SCM, source code management hook trigger. The SCM hook detects changes in the code and initiates the CI/CD pipeline. We can enable and disable it for the pipelines as per our choice. If we want our CI/CD pipeline to be fully automatic, and when there is some code commit or any changes in the code, it should run, then we can use this SCM hook, and that would trigger our CI/CD pipeline. Question number 35. Why DevOps is incomplete without CI/CD? And you have to prove it. So we are going to prove it definitely, because CI/CD is obviously the backbone of DevOps. Because of the following perks we enjoy having CI/CD pipelines. So these are the perks, these are the benefits that I have listed here with the help of CI/CD pipeline. So guys, these are actually the advantages or benefits of a CI/CD pipeline as well. So you can answer these 8 points if you're asked about the benefits of CI/CD pipelines. Number 1, we can deploy the code faster, we can avoid outages, improve visibility across development, we can reduce cost of delivery, cut down on manual debugging, and enhance code quality. Number 7 is to get feedback continuously. And the number 8 and last point is to simplify rollback. If our code fails, our CI/CD pipelines or build fails, we can quickly roll back so that it won't affect our business or our clients. Question number 36. How did you manage secrets if you used Ansible and Terraform in the CI/CD pipelines? Guys, these tools are now also frequently being used in CI/CD pipelines. Ansible is for configuration management, and Terraform is for infrastructure is as code to build our infrastructure on the cloud using Terraform. And Ansible Vault is used to handle secrets, and HashiCorp Vault is used for Terraform secrets. So when we are using Ansible, we can use Ansible Vault in our CI/CD pipeline to store secrets, and when we are using Terraform, we can use HashiCorp Vault for storing secrets. Question number 37. How does infrastructure as code, Terraform, fit into CI/CD process? How we can use infrastructure as code tool is like Terraform, and it is the key component of modern CI/CD processes. It is, by the way, infrastructure is as code is a process to build your infrastructure while writing the Terraform files, .tf files, and it would. There are other tools like code formation as well, but infrastructure as code tool like Terraform is used to build infrastructure on the cloud, and it is the practice of managing and provisioning infrastructure through machine readable definition files rather than physical hardware configuration. So we have those Terraform files, we have configuration files, YAML files to build our infrastructure, and Terraform is the most popular infrastructure as code tool. Question number 38. What is a blue-green deployment strategy? And the answer is, it is a deployment strategy which reduces downtime and risk by running two identical production environments called blue and green. So we have two environments. If one fails, so we can quickly set our info. So there are two identical environments running every time. If one fails, we can quickly switch to the one which is running fine. Our second last question: how Docker and Kubernetes work together in a CI/CD pipeline. These are also two major tools work along with CI/CD, and Docker is used to package our applications into containers, whereas Kubernetes is used to orchestrate and manage all those containers in production. So we can use Docker to build images in the CI part. So Docker is being used in CI, and Kubernetes would be used in CD, continuous deployment. And GitHub Actions is a tool which uses Docker to build artifacts or Docker images, and we can deploy those Docker images into containers in a production environment using a continuous deployment or continuous delivery tool like Argo CD to our Kubernetes cluster. And the last question, question number 40, how do you measure the success of a CI/CD pipeline? How can I assure myself that my CI/CD pipeline is a success? So there are three parameters which involve tracking and analyzing several metrics. For instance, pipeline time, the amount of time our pipeline takes to run, and from a code chain to a production. We are writing the code, and that code is directly going to production. How much time our CI/CD pipeline has taken, and the deployment frequency, the number of deployments that take place in a certain amount of time. More deployments means that our pipeline is a success. And mean time to detect, MTTD, and if there are any issues, how quickly we have fixed those issues in our pipeline. So that is actually MTTD, and with that, our questions have been finished. So these were actually 40 CI/CD top questions that are most frequently asked in DevOps interviews. So I hope that these questions will help you to crack the CI/CD part in your ongoing if there are any DevOps interviews that you are going to prepare for, and I would wish you best of luck for that as well. My goal is to help you by any means, and that's why I have shared Docker interview questions and answers, Git interview questions and answers, and Linux interview questions and answers. So now we have CACD interview questions and answers. If you have prepared all these questions with your answers, I'm pretty sure that you would rock in the interview, and you would be going to answer all of these questions if they're asked, because most of the times these questions are asked interchangeably. So you must know the basic concepts. You must know these are actually the core concepts that I have been gathering in my interview questions and answers series. So in the next chapter, we are also going to have a Jenkins interview questions and answers. So please make sure that you subscribe my channel, you like and hit the subscribe button. I will watch you in the next video. Take care. Bye.